Let's talk about ellipses. Ellipses are formed first by putting down your two foci. So if I have a focus here and a focus here, and I have a fixed length, maybe a string, and I put a pencil in the string there, and I pull it as tight as it will go. Well, when I outline the shape, I'll get the form of an ellipse. If this is the ellipse, you can see that if I pulled taut with a pencil there, the string D1 and D2 would be constant. Of course they would be constant because that is the length of the string. So for any ellipse, D1 plus D2 will equal some constant K. Well, in fact, the constant K is the major axis. So we could say that that is equal to 2A. Why is that? Well, let's look at, if I put the string over here, you can see that this distance is repeated twice. If I put it here, then I'm going across the major axis, and that constant would in fact be 2A. When we're talking about ellipses, let's not lose sight of the fact of what we're looking at here. It's a conic section, so it's a double napped cone intersected with the plane. Now, when we were talking about a circle, the plane cut straight across. Now it's kind of going at an angle, and the shape we get in the cross section is no longer circular but elliptical. If we're looking at the general formula of any conic, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, remember that bxy involves the rotation of a conic. So if b is 0, meaning we don't have an xy term, then our orientation of the conic will either be horizontal, like this, or vertical, like this. If you want to find out if the conic section is an ellipse, of course you could complete the square, or you can quickly look at A and C. If the coefficient of the x squared term and the coefficient of the y squared term are both positive, meaning when I multiply them, I get a positive number greater than 0, and A is not equal to C, then we have an ellipse. If this is a 4 and this is a 5, it's an ellipse. If this is a 10 and this is an 8, it's an ellipse, etc., etc. They're going to be two different positive numbers. Now, if they're both negative, I could multiply the whole equation by -1 and make them both positive. Let's look at an ellipse with a horizontal orientation. Remember, with ellipses, it's the size of the denominator that matters. X minus h squared plus y minus k squared equals 1. The numerators alone would make one think that this is a circle with radius 1. However, we complicate matters by dividing by two different denominators. A, by definition, is center to vertex. So here is our center, HK. This distance along the long way is called A. So when I say A, I'm talking about this distance. Well, if I have A and A going in two different directions, horizontally left and horizontally right, what these end in are vertices. So at the end of the 2A, we have a vertex in each direction. So this is a vertex, and this is a vertex here. Note, if A is under the X, then A will be horizontal. A is always bigger than B. So we can say B squared plus C squared equals A squared. Of the three variables we're going to talk about, A is the largest. And 2A together will make what we call the major axis. So the vocabulary is the major axis is horizontal. When we talk about horizontal orientation, we're talking about the orientation of the major axis. Well, perpendicular to A is B. And so now 2B, the distance across the ellipse this way, is what we'll call the minor axis. So we have major axis and minor axis. The distance from center to the focus is C. Now, A is always the biggest with an ellipse, so we'll put that alone. We can use this Pythagorean relationship to find C. This distance here is C. The eccentricity of an ellipse is a fraction. C over A. If C is very small compared to A, then we have a eccentricity, which is always going to be a fraction or a decimal between 0 and 1. If C is very small compared to A, we'll get a very circular ellipse. If C is very big compared to A, like 9 out of 10, then we'll get an elongated, almost pancake-shaped ellipse. If we want to consider an ellipse with a vertical orientation, notice x minus h squared plus y minus k squared equals 1. The order hasn't changed. It's the size of the denominator. Look to the bigger denominator. We know that A is always bigger than B. A is always bigger than B with an ellipse. With an ellipse, one more time. With an ellipse, A is always the biggest. So if the biggest denominator is under the y, then from our HK center point, we're going to go up A and down A. We say our vertical axis is our major axis is vertical now, and our minor axis, 2B, is horizontal. Everything else remains the same, except we're now in the vertical orientation. Here is C. Notice C and A are always on the same line, which is the major axis. The eccentricity remains C over A, but now you're going C and A, not in the horizontal direction, but now in the vertical direction. Some advice with problem solving and using ellipses. I would say get the equation first and realize what the equation allows you to do. For example, if I'm given a semi-elliptical tunnel with a width of 50 feet and a height of 20 feet, I'd want to put my center right there, which allows me to say that this here is A, 25, and now B is 20. We have a horizontal orientation with HK 0, 0. So it will be x squared over 25 squared plus y squared over 20 squared equals 1. Now, any kind of question they ask us, it's usually in this type of situation, they're asking, can a truck fit under? Well, if the truck, say, if we're drawing the truck here, and they say, can the truck fit? Well, they'll give us the dimensions of the truck. If the truck is 10 feet wide and 12 feet high, for example, well, then we're asking of this equation, at x equals 10 is the height of the ellipse, because this equation gives points only on this semi-elliptical shape. Semi-elliptical because the other part of it goes into the ground there. They're asking, when x is 10, compare the height of the truck, 12 feet, to the actual height of the ellipse. And if the truck is going to fit, we're hoping that when x is 10, y is greater than 12, for example. In other cases, they're asking, where should we put the foci, or the foci? So you're looking for C, and you've got to remember, your Pythagorean relationship is b squared plus c squared equals a squared, because a is always the largest with an ellipse, and so you're going to be solving for C. You've got to read the problem and then try to interpret, what does that mean for my equation?